Today we're exploring one of the most rigorous and revealing benchmarks in AI code evaluation, LiveCodeBench Pro, a test that pits large language models, LLMs, against real competitive programming problems curated and annotated by human Olympiad champions. If today's frontier in AI isn't just about can it read code, but can it think deeply about algorithms and problem solving? LiveCodeBench Pro is designed to answer that question. The landscape of code benchmarks has evolved rapidly. Early tests like Human Evil and MBPP focused on basic function writing, neat, isolated snippets where many modern models perform impressively. But practical coding, especially the kind that distinguishes expert human programmers, requires algorithmic depth, inventive problem decomposition, and robust reasoning across non-trivial inputs. LiveCodeBench Pro emerges from this gap. It's not about trivial code synthesis. It's about challenging AI on real competitive programming problems, the same kinds that elite coders train on for competitions like Codeforces, ICPC, and the IOI. At its core, LiveCodeBench Pro is a benchmark composed of hundreds of competitive programming problems drawn from premier algorithmic contests, captured in real time as they are released to avoid contamination from public solutions or discussions. A team of Olympiad medalists manually annotates each problem with algorithmic category, for example, dynamic programming, graph theory, data structures, difficulty tier from easy to extremely hard, cognitive focus, distinguishing knowledge, heavy, reasoning heavy, and observation-intensive challenges. This expert labeling ensures that the benchmark isn't just large, it's meaningfully structured to reveal genuine reasoning gaps in current models. Unlike isolated test suites, LiveCodeBench Pro continuously updates as new contests unfold, maintaining a moving target that's robust against overfitting and historical leaks. LiveCodeBench Pro evaluates models at scale using metrics that reflect real coding performance. Facet 1. The proportion of problems solved correctly on the first generated attempt. This prioritizes robust reasoning and precise output over brute force retries. Difficulty-adjusted ELO ratings. Borrowed from competitive programming, ELO ratings map model performance to a human comparable scale, revealing where models stand relative to human competitors across varied problem sets. Fine-grained error. Diagnostics beyond raw scores, medalist reviewers analyze why models fail, distinguishing logic errors, misunderstanding of problem conditions, and superficial pattern matches. These diagnostics aren't just academic, they help quantify where current systems fall short and why. When tested on LiveCodeBench Pro, even state-of-the-art models today show substantial limitations. On medium difficulty levels, the best models achieve around 53% pass at 1 without external tools. On hard tiers, certain benchmarks record 0% success among current LLMs, a stark contrast to human competitive programmers who routinely solve such problems. Models tend to perform reasonably on knowledge-heavy algorithmic tasks with clear templates, but they struggle under logic-heavy or observation-heavy conditions where creative insight or deep case reasoning is required. These results underline a core truth. LLMs today may write syntactically correct code, but they don't yet reason through complex algorithmic challenges at the level of human experts. LiveCodeBench Pro stands at the intersection of practical engineering and deep reasoning evaluation. Unlike benchmarks that merely test isolated code generation or simple transformations, it reflects real-world computational thinking, algorithm understanding, interpreting non-trivial problem statements, designing efficient solutions, choosing appropriate data structures and strategies, handling edge cases, ensuring correctness across hidden test cases. This is more than syntax, it's algorithmic intelligence. As developers and enterprises increasingly rely on AI for coding, benchmarks like LiveCodeBench Pro help clarify what models can and cannot do reliably, especially in contexts where correctness, efficiency, and deep logical structure matter. You can explore LiveCodeBench Pro by visiting the official site for insight into its purpose and tools, and by checking out the GitHub repository where the benchmark code, setup instructions, and problem sets are available for researchers and developers. Together with associated research, for example, the NeurIPS/ArcSIF papers on its design and expert curation, these resources make LiveCodeBench Pro a practical place to assess, compare, and advance LLM coding and reasoning capabilities. Thanks for tuning in to Vectoring AI. If you enjoyed this episode, don't forget to like, subscribe, and share the channel. Stay with us as we continue exploring the unfolding journey of artificial intelligence.